Good morning, all. In this class, we'll discuss about the gear material and law of gearing. So basically, to manufacture the gear uh, or to design the gear, we have different types of materials which are available in market. But to select the proper appropriate material uh, for the gears for various applications, there are some criteria which we need to understand. First is selection of material is completely depending upon the strength of that particular part and the actual service conditions. Like there should be less wear, there should be less noise during motion transmission or power transmissions, we can say. Then we have different metallic materials are available for the design of that particular gear. We have cast iron steel, then we have plain carbon steel or alloy steel and bronze. These are the metallic materials which are available for the development of gears. Then we have non-metallic materials like wood, compressed paper, or nylon, which is used to reduce the noise. And really, we are using this part for small applications. And mostly, people are using phosphor bonds, which is widely used for one gears in order to reduce the wears of the worms. Okay, so these are the some materials which we are available for the design and development of gears. So we'll try to understand what is the law of gearing. So basically, we have discussed this part of involute and cyclodal. So I told you that involute gears, the pressure angle will remain constant. Okay, so these gears are straight gears having constant pressure angle throughout the surface. Okay, and it is used to transfer constant velocity ratio. This gear is also known as positive drive with conjugate profile, which is having less wear and tear between the uh, surfaces of the two surfaces of gears. So what we have total length of path of contact. So first is approach distance and second is recess. Now what is approach? So it is the distance at which engagement of gear will start, and second is recess, means it is the distance at which disengagement of gear will start. So we need to understand how gears are engaged and how gears are disengaging during the motion transmission. Okay. Now we'll try to identify how we are transferring the velocity ratio during motion transmission. Now just look at the arrangement. So we have simple pinion and wheel. Okay. So one is the input gear, second is output gear. Okay. Now what we have, this O1 and O2 are nothing but center of that particular gear, and the velocities of gears are omega 1 and omega 2. So we have this center distance O2P and O1P. Okay, which we can define in terms of diameter. So this center distance we can define in terms of diameter. D2 upon D1 is equal to T2 upon T1. So this is the velocity ratio. So it is the ratio between diameter of two gears. It is also ratio between the number of T's between the two gears. It is also ratio between the velocities of two gears. Okay. So in order to have constant angular velocity for all the positions of wheels, the tangential line must pass through the pitch point. Okay. So if common normal at the point of contact between pair is passes through pitch point, then it satisfies the law of gearing. So P is the pitch point where we are having engagement of pinion. Like in this previous part, I have shown this. This is the point P. Okay, so where gears are engaging to each other. So that point we need to consider at the pitch point where teeth are engaging and we are transferring the motion between the pairs. Okay, so this is the fundamental conditions which you need to understand whenever we are designing any gears. So common normal at the point of contact it always passes through the pitch point. Then and then it satisfies the law of gearing, and then you will get the constant velocity ratio between the gears. Okay. Now just look at the arrangement. This is we are discussing. So this is the involute tooth profile having pressure angle constant, and motion is transferring from this surface, and this common normal is uh, passes through the pitch point, which is the pitch point we are engaging, and this is a common normal which passes through the pitch point. Okay. Now next part is what is the difference between involute gear and cyclotron gear. Okay, so basically involute gears the pressure angle is constant. Okay, so we can say that center distance of pair involute gear can be vary. We have within the limits without affecting the velocity ratio. So whereas in cyclotron gear that is not the true condition. Okay, now again pressure angle from start to engagement of gear to the end of engagement, it always remains constant. So whereas in cyclotron gears pressure angle is maximum at the beginning of engagement, and that pressure angle will get reduces, okay, to the zero at pitch point, again start decreasing, again it become maximum at the end of engagement. So basically pressure angle is only maximum at the start and at the end of engagement, and at the pitch point in case of cyclotron gear that pressure angle will going to reduce, okay, and it will become zero at pitch point. Okay, so it has smooth running and less wear of gears, so whereas less smooth running of gears in case of cyclotron gear. Next, in involute gear, the face and flank of involute teeth are generated by single curve. It has straight curvature. That's why we can say that the face and flank for this arrangement is we can develop with the help of single curve. So whereas in cycloidal curve, we have epicycloid and hypocycloid type. So it is difficult to manufacture because it has a double curves. Okay. So based on the nature of that tooth profile, we need to develop these cycloidal gears. Okay. Then the involute gears are less strong. Cycloidal gears are wider flanks because it has a variable pressure angle. So these gears are a little bit stronger as compared to involute gear. Okay. Then interference is more in case of involute, whereas cycloidal interference is less. Again, it is less weighted and it is outdated. So this surface is little bit large as compared to involute gear. So these are the basic difference between involute and cycloidal gears. Okay. Now, one more important part is we need to understand how we are developing these gears with different pressure angle. Okay. Now, basically, we have 14.5 degree full depth system. Then we have 20-degree full depth system is available, and 20-degree stub involute system is available in market. Okay. And based on this various tooth arrangement, we have some values of addendum. So basically, addendum is one module in case of 14.5-degree full depth system. In case of 20-degree full depth system, again addendum is one module. For 20-degree stub involute system, addendum is 0.8 times more. Okay. Now, addendum value is 1.25 module in case of 14.5-degree full depth system. In case of 20-degree, again it is 1.25, and for 20-degree stub involute, one module. Working depth is 2 module, whereas in stub involute system it is 1.6 module. Now, minimum total depth, okay, that is 2.25 modules in case of 14.5 degree. Again, for 20 degree it is same, okay, and for 20-degree stub system it is 1.80. Then tooth thickness 1.57 times module for all these cases. It is 1.7 times module. Okay. Then minimum clearance which we are providing to avoid the jamming or locking of gear, that is 0.25 times module, 0.25 times module, 0.2 module, and fillet radius which we are providing, that will be 0.4 times module in all these cases. Okay. So important part is as we increase the pressure angle from 14.2 to 20, the tooth is become stronger. Okay, and it is acting as a beam as wider at the base. Okay. Then next part is we have discussed about the path of contact. So basically this is the distance Kp and Kl. So total length of path of contact will be Kl, and that Kp is approach and Pl will be the resist. Okay. Now just I will brief you about the how we can define the path of contact in all these cases. Okay. So basically this path of contact distance is responsible whenever we are calculating contact ratio between the tooth surface. At that time, we need to define the path of contact. And just look at the gear surface which we have. This is involute system, okay, which is having straight pressure angle and constant. Oh, this surface pressure angle will remain constant throughout the surface. Okay, whereas in case of other uh, pairs, epicycloidal or hypocycloidal, this pressure angle may get vary. Okay, and that's why the wear and tear is more. We can say interference occurrence in case of this involute surface is more as compared to cycloidal gear. Okay, this is the difference and all about the uh, pressure angle related to these two types of teeth surface, involute and cycloidal. Okay, so we'll stop here. In next class, we'll discuss in detail how to find out path of contact, path of approach, and path of process for a gear.